Hello everyone. In this video I want to look at the question, find the vertices, foci, and equations of the asymptotes for the hyperbola 25y squared minus 9x squared equals 225. To solve a question like this, the first thing I want to do is I want to put it in the form I'm more used to, one that resembles the general form for a hyperbola. And for starters, the best way of doing that is we need to focus on our last term here. It should be a 1, obviously it's not. So we're going to change it into 1 by dividing it and, of course, the other side of the equation by the same number. In other words, we're going to divide it by 225. So I'll have, again, 25y squared minus 9x squared equals 225. And I'll divide everything by 225. So the main thing I want to do is, if I don't have the number over here on the right equal to 1, I'll divide by whatever I need to make it equal to 1. And these will reduce. 25 and 225 can reduce to 9. So now I'll have y squared over 9. 9 and 225 reduced to 25, so x squared over 25. And of course I have 1. Now I have a more familiar form for this hyperbola. Y squared over a term minus x squared over a term equals 1. That matches up to my general form, which is y squared over a squared, x squared over b squared. So again, given my form, that should be a 9, excuse me, make that more like a 9. So, from here we can determine that my a squared is then 9, my b squared is 25, and then I can say that a is 3 and b is 5. Now recall, this also means that because the y squared is first, the way hyperbolas work, or these equations work, if the y squared comes first, since a squared and b squared stay in their respective positions, that tells us that the orientation of this hyperbola is along the vertical axis. Had the x squared been first, the orientation would have been along the transverse or the horizontal axis. So it basically means that our hyperbola, if we were to sketch it, would look something like this. Now to find my value of the foci, I want to use the general equation, a squared plus b squared equals c squared. This is the relationship that a, b, and c have in a hyperbola. I make my substitution, so I'll have 9 plus 25 equals c squared, which gives me c squared is equal to 34. And I can't break it down any further, so I'll leave it as the square root of 34. So I have values for a, b, and c, which when it comes to finding vertices, foci, and such, that's the thing to do. Find those values for a, b, and c. Now, I'll come back to that basic graph for later. Sketch. To find the actual vertices, since my y squared came first, and the graph's oriented along the vertical axis, I have this general form, 0 plus or minus a, and 0 plus or minus c for my vertices and foci respectively. And then for my asymptotes, the equations of the asymptotes, I have plus or minus a over b x. So my a in this case was 3, so 0, 3, and 0, -3 are my vertices. My foci, the value for c was the square root of 34. So 0, square root of 34, 0, negative square root of 34. And since the value for b was 5, my two equations are going to be 3 over 5x and y equals, I should say, negative 3 over 5x. So now I have my vertices, my foci, and the equations for my asymptotes. And the asymptotes, the equations for the asymptotes come from my grid here. Since we're oriented along the vertical axis, a and negative a, b and negative b on the horizontal axis. Remember, the asymptotes go through the corners of this box. This is called our central box. The asymptotes are the lines that go through those corners and through the center. We use those to help shape our graph.